main risk to first-line responders is that the fire spreads to adjoining buildings, endangers life in the surrounding area. That's the number one risk factor. The second risk factor is the fluoride emissions compounds from the fire itself. The number of lithium battery fires that we're seeing is exponentially grown over the years, especially in the large metropolitan areas where there are a lot of e-scooters and a lot of e-bikes. So we're seeing that in the municipalities, in the areas where they're using a lot of the e-scooters and the e-bikes. You're also seeing electric vehicle fires that are involved in an accident, potentially on an interstate or on a highway, where there's an external fire that causes the thermal runaway in the electric vehicle. We are also seeing incidents of thermal runaway in charging stations, whether it's at your home or whether it's in a public area. Those are the main incidents of lithium-ion batteries that we're seeing right now. As I mentioned before, the major hazard is the fluoride chemicals. Every lithium-ion battery has an electrolyte. It's basically the blood. It allows the electricity to flow back and forth through the battery. That material, that electrolyte, is an organic material made up of a fluoride chemical, a lithium fluoride chemical. So as the battery, if it does go into thermal runaway by internal means or an external fire, it overheats, it will basically relieve itself and spread these fumes, which are part of the electrolyte. That is the first main hazard, is the fluoride chemicals. Well, if you look at, if it's an isolated fire out on the street, something like that, it's probably not going to be a major impact. Where I think it's a real issue is in e-bike stores, scooter stores, charging people that are charging multiple scooters or multiple lithium-ion batteries in an enclosed area without ventilation within a main structure, because then you have if that lithium battery does become part of a fire, an incipient fire that grows, it will spread throughout that building. And the lithium ion battery fires are very hot. They produce extreme heat, which can set structures on fire. So that's the main issue, where the fire spreads to a commercial area where it really impacts the business. I think as far as severity goes, the first main issue is to contain the fire. And that's a very typical response with a first responder. He needs to contain the fire. He needs to make sure that people, the public, is not endangered from a spread of this fire, because they need to, when they approach this fire, they need to realize that this fire can grow and it can spread. It can, due to hydrogen explosions, it can blow pieces of fire up to 20 to 30 feet away. So that area needs to be cleared. That is the main response. The other is to be careful, is to be prepared for the fluoride emissions that comes from the fire itself. Traditional fire extinguishers would be a water-based fire extinguishing agent. Water is used because of its effect of cooling the fire, so that it's a very important first response. The problem with responding with water here is that once the module, the battery cell or the module, reaches a temperature where it relieves itself into the atmosphere, you now have an opening in that battery that allows the moisture, either from the air or the water that you are applying to it, to be in direct contact with the internals of the battery. The internals of the battery are going to have elemental lithium in there. That lithium, elemental lithium, is going to react with the water, and it's an exothermic reaction, produces a lot of heat, produces a lot of hydrogen, and as that fire evolves with the application of water, that the temperature will increase and the amount of hydrogen generation will increase to the point where you may reach a detonation standpoint with the hydrogen. Well, some of the challenges that the conventional fire extinguisher doesn't need is the fluorides within the battery and the elemental lithium that can be present depending on the state of charge in the battery. Conventional fire extinguishing agents and extinguishers are not designed to handle, to mitigate the risks of the lithium metal as it reacts with moisture in the air and reacts with water in the potential agent itself. And then fluoride, they're not designed. The more fluoride, the more water and the more moisture that is allowed to react with the electrolyte, the potential of hydrogen fluoride gas and liquid acid is a real challenge that needs to be mitigated. Well, I think the traditional is water. Okay, a water-based fire extinguisher is basically going to cool the fire, but then it's going to reignite, and there's going to be a reignition scenario that happens after you apply water. This could happen multiple times. This could essentially happen until the elemental lithium and until the battery has reacted and the lithium battery itself has cooled to a point where there's no fire issue. So the timing and the amount of water that is required to put out a lithium battery fire, all that water that you put on a fire becomes a hazardous material because of the fluoride concentration in that effluent, and the uncertainty that there is still reactive material within that battery that could start a reaction again at any time. There have been incidences where 2 weeks after an EV fire has caught on fire, that it's in the scrapyard and it sets itself on fire again. That one of the cells that was involved in the fire reacts with moisture, and you have the thermal runaway again. You also have a fire. So the post reaction to putting water on it is a huge risk. The powders, the typical fire extinguishers that you see in a commercial building or at your house that are a powder. The powder it's not designed to get down inside the opening of once the battery cell itself relieves itself, there's a small opening there. And so if you want to get down into the source of the fire, you have to have that powder get down inside that in that cell, and it's very difficult to do that. And that's why powders are very ineffective to that. There's also basically some blankets and where you can basically put the fire out, take the oxygen away from the fire. That's pretty typical of fire chemistry to eliminate the source of the oxygen. But here again, after you take that blanket off, are the chance of reignition, because that breached cell or breached house is open to the air, open to the moisture. You're going to have a potential of a reignition of the fire. So when you use those type of fire extinguishing agents, that might be the only thing that's available. You need the first responder needs to be aware that there's always going to be the potential of reignition and a post reaction after you think the fire is out. Well, I think the products that are currently out on the market do not react with the active materials within the battery, okay, in order to shut down the reaction, to stop the exothermic reaction, to stop the generation of hydrogen, to stop the generation of heat, and stop the spread of fluoride chemicals. So I think that, and a fire extinguishing agent designed for lithium-ion batteries needs to address these three items. And a lot of the products out on the market weren't designed specifically for to eliminate and to have these issues taken under control. Well, the issue with the ineffective tool is, or the scenario of let it burn, is the unexpected consequences of the water in the air or the water from the atmosphere getting inside of the breached battery. Once that happens, you've got an uncontrolled reaction. You don't know if it's going. You've got the risk of hydrogen explosions, reaching a hydrogen detonation, where that battery fire spreads to blocks. You also have the issues of the fluoride, the hydrogen fluoride in the air emissions and in the water effluent if water was applied. The FCL-X was developed by our team of lithium scientists. We have over 100 years of lithium processing and firefighting experience. We developed this product to be able to handle fully charged 100% state of charge batteries, lithium-ion batteries in our recycling application. So when we went down this development path, we knew we had to have a solution that would allow us to process batteries and recover the maximum amount of lithium. And so this is how the FCL-X was originally developed and patented for that application, and then later expanded to because of its extinguishing properties, exactly how it was designed to work in the recycling application. It works in the real life scenario of a fire. The design of the material is to do two things. Is react with the fluoride in the electrolyte and make an insoluble salt that will not go airborne and will not go into the effluent. The second is to buffer the lithium metal, elemental lithium reaction with water. Our material is 98% water. So in order to take advantage of that water and the cooling characteristics of that water, we needed our active ingredient in the FCL-X allows to buffer the elemental reaction with water to minimize the amount of heat generated and the amount of hydrogen generated until the material encapsulates the lithium, the elemental lithium, where it now is coated with and it's secured, it's neutralized to where it does not react with the water in the FCL-X, or it does not reignite. Yes, and so after we developed this product for our internal use, we went to a third party in North Carolina that was experienced with battery safety testing. There is no UL or NFPA standard for an extinguishing agent for lithium-ion batteries. So there's currently no standard for that. So we used the third party, Safe Labs, developed a protocol, a test protocol that was based on battery safety standards. So we basically take a set of different sizes, 3 different sizes of power capacities of lithium-ion batteries, and set them into thermal runaway with an external heat source with a cartridge heater, which basically heats up the battery cells themselves until they relieve themselves. They're then open to the air. There then is a fire, and then our material was applied in a portable fire extinguisher by a first responder, and the material, the time that it took to extinguish the fire, where there was no reignition, no smoke, and also the amount of material were some of the key parameters that came out of the study. We tested the FCL-X in 3 different scenarios, battery scenario. The first is what we would refer to as a small cylinder battery stack. These were 1865 cylindrical batteries. We set these on fire with an external heater. It reached a temperature of about 540 centigrade, approximately 540 centigrade, which is about 1,000 centigrade or Fahrenheit. The amount of material that it took to put that was about less than 1/4 of a gallon of solution. The time to extinguish was less than 4 seconds. There was no reignition on this fire. So the second test we did was with an e-scooter battery. This was 1 kilowatt hour. These were 18650 MNC batteries. We set these on fire with external heaters. The temperature that we reached was about 650 centigrade or 1200 Fahrenheit. The time that it took to extinguish it with our FCL-X was about 4 seconds. We used about 1/3 of a gallon of solution. There was no reignition after the fire was extinguished. The third test was to simulate an EV battery fire. This was a stack of batteries. This was 57 kilowatt hour prismatic batteries. Basically, we set these on fire with external heaters. The temperature, the maximum temperature we reached was about 800 centigrade, which is about 1,500 Fahrenheit. The time to extinguish this with a portable fire extinguisher was about 15 minutes. We used 120 gallons of solution, and there was no reignition of the fire after the fire was out. Actually, 5 out of the 10 batteries were actually usable and did not see any damage from the fire. The specifications, the technical specifications, is that we sell our product in a 2.5 gallon portable fire extinguisher. This is designed for enough material, FCL-X, for a fairly large lithium-ion battery fire. These designed for incipient fires that are started. Also, this material they're also designed that the FCL-X can be applied to a battery after it's burned out, to basically secure the battery and allow for that it does not reignite in the future, and that it can be recycled in that fashion. The feedback has been pretty phenomenal. Most of the feedback is based around the exposure of the first line responders. They see this, the speed at which our FCL-X puts out a fire is important, because the fire is not allowed to spread. Also, the amount of effluent, fire residue that is in the surrounding area for cleanup, that would require cleanup, is minimized. So these are important factors for a first line responder, and also the ease at which it is to apply the material to the fire. The two issues with a lithium-ion battery that the FCL addresses is the elemental lithium, the reaction of the elemental lithium in the battery fire, and the fluoride in the electrolyte. So the way the FCL-X addresses the fluoride in the battery as it's burning is it reacts and encapsulates that fluoride as an inert salt, which does not allow it to go airborne or end up in the effluent material. The buffering effect, the FCL-X has a buffering effect with the elemental lithium. It slows the reaction down. This is a heat generation and hydrogen generation, to the point at which the FCL-X armors the elemental lithium, which stops the reaction, the heat generation, and the hydrogen generation, and neutralizes the battery to where it will not reignite. The benefit to the FCL-X is that not only does once the battery is put out, it prevents reignition, so that the first line responder or the user in the commercial application knows that this fire residue is not going to reignite. The other additional benefit is that Our FCL-X is compatible with our recycling application, our process, sorry, in Georgia, and allows us to recycle that fire residue. So instead of a first responder or a commercial fire response team having to send this fire residue off as hazardous materials to a hazardous waste disposal unit, they can send it back to us, where the lithium values and the other materials in the lithium-ion battery can be recycled. The majority of the hazardous smoke in a lithium-ion battery is generated by the fluoride, the organics and the fluoride chemicals in the electrolyte. So by reacting, the FCL reacts with those fluoride salts to basically neutralize them and allow them to be in a stay contained within the battery, not go airborne and not go into the effluent stream. Also, the buffering effect of the lithium, our FCL-X on the lithium, slows the heat generation, which basically steam that might be evolved from a fire of that temperature is minimized, and any fumes, any smoke from the fire itself is minimized. Training is integral to basically the success of our product and how it's used. So we're very focused on training programs, firefighters and first responders and manufacturers that are using a lot of lithium-ion batteries. We train them, we do live demonstrations, we do training with them. In the future, we look to build a training facility at adjoining our Georgia facility, where we can quarterly bring in first responders and users of lithium batteries to practice in a controlled environment on the type of fires that they're seeing in their real life scenarios. The major environmental and safety risk of a lithium-ion battery fire is the fluorides, the generation of hydrogen fluoride. The FCL-X, because it binds and reacts with the fluoride salts in the lithium-ion battery during the fire, minimizes the amount of fluoride that is converted to hydrogen fluoride, which then could become airborne or could become soluble in the effluent. So the fluoride risk is really the largest risk to personnel. Fluoride concentrations can reach close to the lethal level for hydrogen fluoride and fluoride gas. So this is an important benefit of our FCL-X, is that we bind up that and encapsulate that fluoride so it does not become a fluoride hazard to the first responders or to the public. I think the FCL-X is a incipient fire tool for incipient fires. So it should be made available to first responders that are responding to EV fire, scooter fire, any lithium-ion battery fire. It should also be made available for the aftermath. Let's just say the first responder, it's a small scooter battery, and that scooter battery fire has already burned itself out. It's smoldering by the time the first responder gets there. The FCL-X can be used to basically further cool that fire residue to the point where it will not reignite. So it eliminates the hazard of that a continued reaction, a reignition scenario. And then it also allows for that material to be recycled. We're working to add a containment kit, a response kit to our portfolio of products, where the first responder and the hazmat team could then collect that fire residue, ensure that it was cooled, package it in the FCL-X, and send it back to Circle Lithium in Georgia for recycling, full recycling. Keep these materials out of the landfill, hazmat landfill, and certainly out of our local landfills. We don't have a minimum order quantity. We do have a price break for quantities over 10 of the fire extinguishers. And then so we sell the 2.5 gallon fire extinguisher for the first line responders to put on their vehicles, to be positioned within a facility that's handling lithium-ion batteries. And then we sell a 50 gallon drum to refill those fire extinguishers. Some of the large stations are looking at refilling their own fire extinguishers. We are considering in the future providing a service for the smaller stations and the smaller facilities that want to send back a fire extinguisher and after it's been used to be reserviced. But at this point, we have two products that we're selling. That's the 2.5 gallon fire extinguisher and then the 50 gallon drum to be able to refill fire extinguishers by the local fire and rescue services. Certainly go on our website, send us an email and request a quotation for the product that you'd like to have and the quantity, and we'll respond to that. Depending on the quantity, typically our lead times are less than 30 days to be able to supply your order.